Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome to Mr. Math Academy. So in the previous video we have done that is Hooke's law and basic properties of the material. So today in this video we will go for the continuation of the Hooke's law, that is the principle of superposition and some of the numericals which based on the principle of superposition. Now actually I have given one problem here. So this kind of problems are important for the examination point of view. He might be given for the 8 to 10 marks sometimes. Okay. Now what we have to do here is, so now we just recall what we have done like Hooke's law here. So because that gives the information regarding how to solve this kind of problems. So we know that Hooke's law is given by what? So it is stress is directly proportional to strain. Okay. Now after when we remove the proportionality constant, what we are getting here is it's a sigma is equal to E by epsilon here. Okay. Again we have cross multiplied here so that we can get the E is equal to sigma by epsilon. Okay. Now where E indicates the Young's modulus of a material. Okay. Now which measures the stiffness of a material. Now sigma is nothing but it's a load per unit area. Again I just simplify here so that we can calculate what is the change in length for a material when it is subjected to a different kinds of load. Okay. Now sigma is given by, it's a P by area, that is a load acting per unit area. So again the strain is nothing but it's a change in length to the original length. Okay. It's a delta L by L val. Okay. Now after simplification what I can get here is it's a by B whole divided by C by D formula. Okay. It might be a PL by A into delta L, what I am getting here. So our intention is, so we need to find out the change in length when it is subjected to a load. So I just take delta L is equal to PL by AE. Okay. Now this is the basic formula to calculate the change in length for any member when it is subjected to a load. Okay. Now this we have to remember for throughout the calculation purpose, that is change in length delta L is equal to PL by AE. Okay. Now we will go for the numerical here, that is the important one. Now what is the principle of superposition says means the total change in length, it must be equal to the algebraic sum of all the change in length of individual elements. If suppose, so there are three elements. If suppose if I am taking this is the one element 1, 2 and 3. For complete one member I am having a sub element 1, element 2, element 3. So if I take this is the element 1, element 2 and element 3, which is subjected to a different loads here. Okay. Now in this problem, so he has given some of the data here. We just go that one. Okay. So he has given that. So P1 is given at point A, P2, P3, P4. These are the different point loads. So he has given P1 45 kilonewton is given in the problem. If suppose assume. So next P3 is 450 kilonewton if he has given. If suppose again I am taking P4 is equal to some 130 kilonewton. Okay. Now these are the loads what he has given if in the problem. Okay. Now what we have to find out, so we need to find out the two conditions. I'll just take here to find. The first thing is we need to find out what is the P2 value, because he has not given in the problem. We need to find out, we have to find out. The second thing is, so we need to find out the change in length for entire member, total change in the entire member when it is subjected to a P1, P2, P3 and P4 etc. Okay. So we need to find out the total change in length. These two things we have to find out. Okay, let it be. So how to find out the first part? The first part is, so we have to apply the equilibrium condition. So what is mean by equilibrium condition means, so the total forces which are acting towards the left hand side must be equal to the total forces which are acting towards the right hand side. Okay, we just applied that condition for this problem. Okay, I'll go for the solution here. I'll just take the equilibrium condition, so which gives the equilibrium condition gives the total forces towards the left hand side. P1 is there and P3 is also towards the left hand side is acting. P2 and P4 is acting towards the right hand side. I'll take these two terms. Okay, now I'll substitute the values here because these values he has given in the problem. So P1 is 45, P3 is 450. So P2 is unknown, we have to find out because this is somewhat the unknown what we have to find out in the problem. So now P4 is 130 kilonewton. So this becomes 495 is equal to P2 plus 135. Take this term to the left hand side. So this 495 minus 130 is equal to P2 value. Okay. Now finally you just simplify this, you may get around 563. So this is a P2. So P2 is given by 365 kilonewton. Okay. The first part is over. That is by taking the equilibrium condition, which is left hand side forces is equal to right hand side forces. Now the first part is over my P2, which is given by 365 kilonewton, what we have calculated here. Now to calculate delta L total, how to calculate this part is very important here. Now to solve this kind of problems, actually we have to take these sections. Okay, how to take the section is also important. So I just go for the section one by one. So take this is the element 1, element 2 and element 3. We need to take section because this kind of problem we can solve in many ways. Okay, I'll go for the simplest form what I thought. Okay, I'll just take this part here initially. Now this is the first element. Okay, you just take this is the element 1, this part is element 1. So I have taken the section somewhere here like this. Section means I just cut that particular member here so that I can just see this kind of arrangement here. Arrangement means this kind of figure that you can see here. Now in this point, this is actually the P1 value. Okay, so somewhere here you can just see this is a P2. So this P3 is somewhere for this particular point. So on this point it's a P4. So what is this here? So this you can see the forces will be acting opposite in a direction like resisting forces. These are the resisting forces. I have a point A and B, so that I'll represent these forces like PAB, P A to B. So this from this side I can take this as a P B to A, means both are same, only thing is the opposite directions. So this kind of problems we can solve in many ways. Okay, but this is also one of the method how I can solve this problem. Okay, now only for this part I have taken the section here. After taking the section, because you just remember that this is the initial member, when you apply the force in opposite direction like this, so this finger indicates what? It's something like resisting forces. I can go in one more example here. I can go for the one more example. You can just assume that. So this kind of problem will also be there. So just for the understanding purpose, I have taken one small example here. You can just see here. For this member, if you apply load like this, if I apply load here, so this part you can see this is the reaction forces which are acting in the opposite direction. So that opposite direction, it's nothing but the reaction forces are this one when you apply the load here in this particular directions. Okay, now I'll calculate for this part here. Now I'll take the element 1. Now try to apply the equilibrium condition. Equilibrium condition means what? The left hand side forces is equal to right hand side forces. Only for the first element I'll just apply for, because I need to calculate the delta L for AB, delta L for BC, delta L for C to D. Now this figure applicable for only the element 1, because I am taking the section, cutting this only center part of element 1, this part, because this part remain as it is here, this half part is this one. Okay, now from this condition you just take only this half part here. I'll just remove this second part. Okay, now you can see only what I have taken, this half part I have taken. Now by using this condition, so P1 is equal to PAB. I hope you are getting this one, because the left hand side forces is equal to right hand side forces. Now P1 is equal to what? He has given the 45. Now finally this is 45 kilonewton. Similarly, I will go for the second element. So second element means again I need to take the section somewhere here like this. Now again two parts will be there. So this is the element one completely. So this is the second part. So something like it will be there. I hope you are getting this one. So this is the P2 is acting towards the left hand side somewhere here. So this is the P2. So this point is P3. So somewhere here it's a P4 value. So in between section, when you are taking the section means somewhat the resisting forces will be acting on this opposite directions. Then only the material will be in a equilibrium condition. This is because of the bonding here. Okay. So since it is a BC member, I'll take this as a P B to C. Okay. Now for the calculation purpose, either you can take the left or right, any one side you can take. Better I'm just taking the left hand side itself, so that I'll remove the right hand side part. Only one side you have to take for calculation purpose. Now again apply the equilibrium, means left hand side forces is equal to right hand side forces. So P1 is acting left hand side, and again only one thing is there. So P2 and PBC are acting towards the right hand side. So P2 plus PBC. You can take right part also, no issue. You can get the same answer, right? Only thing is any one side you have to take. So this P1 is 45. So P2 we have calculated here, that is 365. So plus PBC. Okay, now take this to the left hand side. The finally PBC becomes 45 minus 365. So which is given by minus 320 kilonewton. Okay, so this you are getting minus value means it indicates it gives a compression to the center part here, because you can just see from the figure itself, because of the P2 it is acting towards the right hand side, P3 is acting towards the left hand side, means what? So at the center you can just see the compression here. Okay, that minus indicates the compression. The entire that second part will be gets compressed here. So means what? The change in length for the second element will also gets compressed, means you will get the negative answer. Okay, now this is for the second condition, second member. Now again I have to write it for the third member also. So I'll just remove this part, I'll directly write the answer. Okay, let it be. I'll just remove this part here. Now I'll go for the third member. So means what? I have to take the section like this. So you just write all the parts here. So you no need to write all the parts here. Only thing is you can, if you know, that's better, but for the understanding purpose better you can write. Okay, this is the section means you just cut that particular part and take it away here, so that easily you can mention. So this is the P1. So this P2 is somewhere here. So P3 is acting towards the right hand side at this particular point, that is a B, C, this is A. So the last point is D. Okay, now P4 is acting towards the right hand last point. So in between, because of the section here, the forces will be acting in the opposite directions on both the sides. Okay, now I'll take this as a PCD. Okay, but for the calculation, to calculate PCD, either you can take the left hand side of the section or right hand side of the section. Because the right hand side is only one force is there, I'll go for that one also. Even I can go for the left side, no issue. So because already I have taken here and here the left hand, so better I'll go for this is a right hand side part. Now this is your PCD. Okay, so this becomes PCD is acting towards the left hand side is equal to P4, the right hand side force. So which is given by 130. Directly we are getting the value here. So means what? You just make a note of this. So solution what we are getting, PAB is equal to 45 kilonewton. So next PBC is equal to minus 320 kilonewton and PCD is equal to 130 kilonewton. These are the forces what we are getting now. Now the after, I hope you are getting this one. Now we'll go for the second thing. So how to calculate the total change in length? So we know that the total change in length, so this total change in length is given by delta L for the member AB plus delta L for the member BC, delta L for the member C to D. Okay. So but we know that equation delta L is equal to what? It's a PL by AE because by Hooke's law. Okay. PL by AE for member AB. Again PL by AE for member B to C. Again PL by AE for member C to D. Okay. Now this PAB, L a length of AB, area of AB, Young's modulus of AB, means this kind of things we have to substitute here. Now again what he has given for this problem data is, so the Young's modulus is constant, Young's modulus is same for all the section here, means so Young's modulus is what he has given is, it's a 2.1 into 10 power 5 Newton per mm square. So this value is common for all the cases because since it is a common same material here. Okay. Now what is changes here is, so it's a PAB. I'll take here PAB, length of PAB. It's a area of A to B, Young's modulus of A to B. Okay. Now again it's a PBC, length of BC, area of BC, Young's modulus of BC, plus PCD, length of CD, area of CD, Young's modulus of CD. So this is somewhat just simplification. Even you no need to write this two equation. You just write this equation directly. If you write this equation, it's a good. After writing this equation, just substitute the values here. No need to write this step here. Okay. Now PAB means, so it's a 45 kilonewton. So I'll take in terms of Newton. Okay, it becomes a 45 into 10 power 5 3 Newton. So length of AB is nothing but this is a 120 centimeter. So in entire problem, so he has given in terms of mm here. So mm is, you just see here area is 625 mm square. So area is given in terms of mm square and Young's modulus is given in terms of Newton per mm square. So means what, the entire thing I need to substitute in terms of Newton as well as in terms of mm. So that's why I'll convert this length of given member in terms of mm. So it becomes 120 into 10. So it is a 1200 mm. So area of AB means it's a 625 mm square directly. So Young's modulus of AB is a 2.1 into 10 power 5. So this is the change in length for element 1. You can calculate this separately. Okay, that gives a better that gives a better solution here if you calculate separately. Okay, now we'll go for the second member here. Even I can take 2.1 into 10 power 5, only the single value, that is a common, because the entire material it is the same, Young's modulus remains same. Even if you take 2.1 into 10 power 5, it's a common, that is outside the bracket. Then if you solve, then also you can get the solution. But try to calculate, okay, like symbol one by one, so that you can get a clear idea about the change in length. What is the change in length for element 1, element 2, element 3 in a separately. Okay, that gives a better solution here. Now we'll go for the second part here, that is a B to C element. So BC is, it's a minus 320 kilonewton. Take as it is what we have calculated here. It's a minus 320 into 10 power 3. 10 power 3 means, so I have taken in terms of Newton. because this Young's modulus is in terms of Newton per mm square, that I need to substitute in the denominator. So that's why this kilonewton is also I have taken in terms of Newton. Now this length of BC is 60 centimeter is given. I'll try to take in terms of mm, so it becomes 600 mm. So divided by, so area of a BC, this member is 2500 mm square. Now in place of this PBC, I have taken minus 320 into 10 power 3, because 320 we have calculated here, we are getting the negative value minus 320 kilonewton. I have taken the same value here because we are calculating for the second element, and the length of BC is, it's a 6 centimeter is given, but we need to take in terms of mm, is it become a 600 here. Again in the denominator area of a BC is given, so it's a 2500 mm square, and again Young's modulus of a BC is 2.1 into 10 power 5, it's a common thing. Now we'll go for the third part, PCD, that is a load acting on the third element, that is a CD is 130 into 10 power 3, that is a 130 kilonewton, it's a positive value. Now length of the CD is 90 centimeter, so we have taken in terms of mm here, so that's why I have written in terms of 900 mm, that is centimeter to mm. Now again the area of a CD is 1250 mm square. What I have taken here, 1250 mm square. Young's modulus is common, even you can take 2.1 into 10 power 5 common, that is outside the bracket, and again you can simplify, finally you will get the solution for the entire member. Okay, but when you calculate like this, you can get this change in length for the each and every element, so that you can get some completely idea about what is the change in length, what is happening for the element A to B, B to C, C to D, etc. Okay, when you just simplify this part here, I am getting the solution is 0.4114. Again this becomes plus into minus minus. Again if you just simplify this, what I am getting the value over here is, it's a 0.3657. Now this is the third part, simplify this one, you are getting a plus 0.4457. Now what is this value indicates means, this 0.4114, it's a change in length for a element 1, that is in terms of mm. What you are getting a positive value means, you can just see this is the left hand side acting force, this is the right hand side, means what, this member is completely elongates here. Okay, that's why this you should be getting in a elongation is there means, so this will be a positive value, that positive value you are getting over here. Now the second member is, you are getting a minus 3.3657 mm, which indicates, so for the second member, because of this load P2 and load P3, it gets compressed here. So that compressed means, so we are getting a minus value here, so because of the contraction here, so this is the value, that is a 0.3657 mm of a member will be gets compressed here. Now again the third part CD is, you are getting a plus 0.4457 mm elongation, again it's a elongation here, that's why we are getting a positive value. Now you just simplify enter all the values here for the first element, second element and third element. Finally I am getting a total change in length for the entire member is 0.4914 mm. Okay, you are getting a positive value means it should be a elongation. Okay, now I hope you are getting this for a problem here. This kind of problems are very important for the examination point of view for 8 to 10 marks here. Now this is one of the problem here. Now in the next video we'll go for the one more problem, which is a different kind, either it may be a compressive or any different structure here. So if you like this video, please comment and share it to your friends, like and subscribe the channel. Thank you.